This is a quick demo to your lab assignment number 2, which is asking you to print the value of each node in a non-empty linked list. So let's just copy over your starter code to here. Now that you're looking at my Visual Studio Code IDE, it's already set up. And the first thing you do is always to format this, right? Making sure, and then try to compile this. And this compiles. I just wanted to caveat this. A lot of times the starter code may not compile for pretty obvious reasons. So if I give you a solution methods here, and this is asking you to return a Boolean or string or something, and your code doesn't, your simple code doesn't have that return right there, value right there, it will not compile. So that's the first thing you need to fix, right? Just to make sure return some dummy and whatnot. So you have a clean slate to begin with, but by and large, your code sits right in here. And the very first thing to make sure is you have the IDE correctly formatted and that your code compiles, okay? Like in this case. Okay, so let's begin. This is your starter code invocation. Invocation instantiates a copy of your node and call on the solutions method print list to print it, right? So if you do print that out to the screen, you should have something like this. So I'm going to paste this in there like this, right? Because there's only 4 nodes, and the very last one is null, right? So this is in general how you would like manually create your linked list. And of course, you can write a function to do that. The choice is up to you, but it doesn't really matter. We don't really care about this. We'll care about the solution to this one, right? And note that your class node in general has a couple of member variables. One of them is val, and the other one is next, right? This is the value of the node, and this is the chain that glues all of the nodes together. Okay, so let's get rid of this. And now that we've formatted our code and it looks good, let's begin. So the very first thing we need to do is to ensure, we have a way of preserving the original head that gets passed in. So this node head is a reference that gets passed in. A lot of times we don't want to modify this, right? What gets passed in as a reference could be easily modified because it is reference, right? It's pointing to a specific locations in memory. So if we modify the head by saying head equals head dot next, then this entire head would have been changed, modified, and that would introduce yield effect to the integrity of your code, because maybe your invoking function doesn't, in this case main, doesn't really expect that, right? So a lot of times we make a copy of it first. You can name it whatever, node, current, or no, right? It doesn't really matter. So I'm going to say current equals head. So now you have a local copy of it sitting inside of this print list. So we want to iterate through this. As long as the current is not null, right? Is not null, then what do? You want to iterate through this one at a time and start printing out the value of it. And that's really what we want. So system out print. Should we use print line or print? Well, notice that the result is asking you for a sequence, right? A line line or not without any line break. So you don't want to use print line. So you use print. And you want to print out the value of it, right? But also there is this arrow. This arrow is pretty artificial. So we have to introduce that arrows here by saying this, basically. Okay, and then we can print. But we're not done, because once you print this out, you want to make sure that you're a reference. So let me just draw this too. Right, supposedly this is what we have. This is 1, this is 2, this is 3, this is 4, right? And this is null. The last one is pointing to a null. Now we start with this. This is your current, okay, which is also your head, right? But we made a copy of it in here. So your pointer is actually here. So what we want to do next is to ensure that we, we move, right, our pointer CURR to the next one, which is at 2. So how do we do that? Current equals current.next, right? Okay, so let's take a look at what this is. Well, remember each node has a member variable, which is called next, right? So this allows us, right, in this case, to move this to the next one, right? This is what happens, right? Current equals current.next, right? That takes us to the next one. And then because of the while loop, it then prints out the very next current value. But anyway, this is it. Let me just run this so you can see it. Okay, now there's a problem at the end. Looks like the cursor, because we're using print, right? We want to make sure that the very next one, right, is null, right? So when you iterate through this entire thing, we want to print out the null. So to do that, we could introduce a null string, and this is pretty manual. You do that. But the very last one is we don't want the cursor to be there. So the very last one, that percent sign, is actually cursor. So you can use the print line to move that cursor out and then print this. Okay, so there we go. This is how you would print the value of each node in a linked list.